Good morning, everyone. My name is Uma. I am from CSBS department. Today, I am going to discuss about the topic the computer architecture with different processors. We need to concentrate on a computer architecture. First of all, manufacturers wants to manufacture anything in any kind of device. First of all, that manufacturers will concentrate on the processor. So if that system has a single process or if that system has a multiple processors, what happening with the single process and what happening with the multiprocessor. So if that device has a single processor, that means everything, every action, every task will be handled by that single processor only. That means the performance may be gradually decreased. Why? Because single processor will take care of everything. If that manufacturer wants to put multiprocessors with that system, it will be very helpful. Nowadays, operating systems are very gradually increasing with the versions. Why? Because majority of the systems may have multiprocessor systems only. So one of the best example for the single processor system is DOS. So DOS is one of the best example. So that is disk operating systems. DOS is nothing but disk operating systems. So in that only single disk is there for it operates everything. For example, I want to open a Word document. If I want to listen a song in the music player, if I want to watch one video from the YouTube. So these are the multiple tasks we are going to perform. So every tasks are done by the one single processor, that is DOS. So the basic version of operating system before operating system, that DOS disk operating systems are very popular. So facing a multiple challenges with the disk operating systems, the invention of operating system is started. The computer architecture means the design of a computer, we know that, and it may be organized in multiple ways. Computer always organized in a multiple ways. Some computer systems have single processors and otherwise some have multiprocessors. So that depends on the manufacturer if that device has one processor or multiple processors. So based on the processors used in the computer system, they are categorized into three ways. That means the manufacturer will put one processor or multiprocessor or clustered systems. So this tells us how the operating system will make some major role based on the processors. So the first category is single processor system. That means in that device only we have one single processor. Second thing, that is multiprocessor system. That means that device contains more than one processor. Third one, clustered systems. That means grouping or combining. Some systems have single process, some systems are having combined multiprocess. Both the cases will be explained in the cluster systems. Coming to the single processor systems. So in single processor systems, that computers only contains one processor, such as microcomputers or personal computers. Majority of PCs has only one single processor. In one single processor system, only one CPU that perform all the activities with the computer system. If you want to do many things with the single processor systems, it's very difficult. Why? Because it has only one CPU and we know that two or more programs or two or more processes will not execute at the same time with the CPU. That is a step-by-step process. Only one single process will execute at a time. So that means if you want to do multiple tasks with the single processor, it's very difficult. And most of these systems have other special purpose processors, but CPU is only one, but it has some other processors, and that IO processors that move data quickly among different components of the computers. And limited system programs in these type of single processor systems, we can do only limited system programs and do not run the user programs. In this running of the user programs somewhat difficult. Why? Because these kind of single processor systems has only one single CPU, and these are also managed by the operating system. And these PCs contain a special purpose microprocessors. For example, in the keyboard we have one kind of special purpose processor. Why? Because when you connect with the keyboard to the computer, automatically that processor will invoke. It's started, but we cannot calculate that is multiprocessor system. Why? Because those are special processors for special hardware components only, but the CPU remains only one. And the use of special purpose microprocessor is common in microcomputers. And a system has only one general purpose CPU. So if that system is only having one CPU, it considered as single processor system only. But in some special purposes, we have some kind of different processors. Keyboard has one separate processor, but we cannot consider that we have two processors. Only the general purpose CPU is only one, so that is a single processor system. Coming to multiprocessor system. So in multiprocessor system, we have two or more processors work together. That means that manufacturer will put two or more processors in the system. And in the system, what is the difference between single processor system and multiprocessor system? In this system, multiple programs, more than one program are executed on different processors at the same time. For example, we have two CPUs, CPU 1 and CPU 2. So I want to open Word document with the CPU 1 and I want to open YouTube at the same time. So now the Word document will be accessed with the CPU 1 and the YouTube will be accessed with the CPU 2. Why? Because we have more than one CPUs in our device. This is the advantage of multiprocessor system. Nowadays we are using almost every device has multiprocessor systems only. And this type of processing is known as multiprocessing. At a time, multiple processors we are using and multiple tasks also we are going to perform. Some operating systems have features of multiprocessing, and one of the best example of operating system is Unix. So Unix is an example of multiprocessing operating system. Some versions of Microsoft Windows will also supporting multiprocessing. And multiprocessor system also known as parallel system. Why? Because we are parallelly executing multiprocesses. And the system is very fast compared to the single processor system. Why? Because only in the single processor system, one CPU will take care of everything. But in the multiprocessor system, multiple CPUs will take care of everything. And we can do number of tasks at the same time. We can execute multiple programs at the same time with the multiprocessor system. And coming to types of multiprocessor systems. How many types of multiprocessor systems? We have two types of multiprocessor systems. First one is symmetric multiprocessor system. Symmetric multiprocessor system. Second one is asymmetric multiprocessor system. Coming to the introduction portion of symmetric multiprocessing system, in which each process is assigned a specific task. In multiprocessor system, in which each processor is assigned a specific task known as asymmetric multiprocessing system. So, one processor we have in the multiprocessor systems, multiple processors we have. So, each and every processor. So, here is the best example for asymmetric multiprocessing system. CPU 1 is specifically assigned for Word document and CPU 2 is specifically assigned to YouTube. Specific task. One processor will works only with the specific task. And one processor is dedicated for running application of a program, and one processor is dedicated for running image processing and so on. That means separate tasks are assigning to separate processors. And one processor works as a master in this asymmetric multiprocessing system, and one is working as a master, and while other processors are working as slaves. That means one controller is there. That controller of master processor will take care of remaining processors what they have to actually. The master process controls the operations of the system. That means opening the YouTube, searching something in the YouTube, watching a video, everything will be taken care of one processor, and one processor will opening a document and doing some activities in that Word document, copying a text, deleting a text, inserting a table, everything, whatever we want to do with the Word document. So separate tasks are assigned to separate processor, and on that every processor there is a master processor for controlling everything. And next case, that is symmetric multiprocessor system. So we know that in the asymmetric multiprocessor system, each and every processor has their specific task. That means processor 1, processor 2, processor 3, processor 4, and these are work with separate tasks. These are works with separate tasks. Already we know that here is, for example, a music player. This is a music player, and this is a gaming, and this is program execution, and this is some other task. For example, opening YouTube or doing some watching some videos in that. Okay, so these are happening with the asymmetric multiprocessor system. And by all these processors, there is a master process, and this master process will take care of everything. This master process will take care of everything, and these all are slaves. And these are the tasks or programs performed by the multiple processors. That is asymmetric multiprocessor system. Coming to symmetric multiprocessor system, in this type of multiprocessing system, all the processors are work on one single task only. For example, so here is a diagram. Multiple processors are work with only one task. For example, the task is music. I want to open a musical application. All the processors, process P1, processor P2, P3, P4, P5, all the processors are work with only one single task, that is symmetric multiprocessing system. So there is a difference here, right? In single processor system, multiple processors are only works on the one single task. In the multiprocessor system, all the processors are their own tasks. They are not work on the single task. Separate tasks we are assigning, that is asymmetric one. In symmetric one single task is we are going to perform one single task by using multiple processors, right? And all processors are treated equally. That means that the performance and the contribution of each and every process is equal. There is no master relationship in this symmetric multiprocessor systems. Simple difference is there. There, separate tasks we are assigning to multiple processors. Here, in symmetric multiprocessing system, only one single task performed by the multiple processors. For example, so here is the diagram we have. Here a dual core design is there. In this dual core design, we have multiple CPUs. So here is CPU 1, that means processor 1. Here is CPU 2. One device has this dual core design. It has one registers for storing some, and it has only separate cache. It has some separate cache, and this processor also contains registers and caches also. Separate memory allocations are also there. And for example, if you want to clear that, I want to give some examples of symmetric multiprocessor system. All the processors shares the same memory. There is no separate memory here. Why? Because multiple processors are work on the same task. And the input data given to the processors and their results must be separately controlled. Must be separately controlled. And today all modern operating systems including Windows and Linux provide supporting the SMP, that is symmetric multi-processing systems. So nowadays any kind of operating system versions, latest version supporting this SMP, that means all the processors are working on the same task. It must be noted that same computer system in some techniques, in some kind of techniques, the asymmetric multiprocessing and symmetric multiprocessing techniques can be used to different operating systems. Sometimes, very rarely, we are going to use different operating systems with the both the cases. Sometimes symmetric we are going to use, sometimes asymmetric we are going to use. And this is a dual core design of multiprocessor system. It has CPU 1, CPU 2. It has CPU 1 and CPU 2. It has same registers, it has own same registers, cache, and it has separate registers and cache, and those are having memory. So only single shared memory. It's sharing single memory, but the processors has separate a small area of registers and caches also there. This is symmetric multiprocessing systems.
Like, share and subscribe. Hit the bell icon for more updates.